Today, we're doing a deep dive into a really critical design pattern for building capable AI, tool use. If you're looking to upgrade your LLM from just a text generator into an agent that can actually do things, well, this is the core concept you've got to master.
So let's start with a fundamental limitation of any large language model. Its knowledge is static, right? It's basically a snapshot from whenever it was last trained. So what happens when a user asks a simple question like, "What's the weather in Lisbon right now?" The model can't answer that from its own knowledge. It's completely disconnected from the live, real-time world. And tool use is the pattern that solves this exact problem.
To really get our heads around this, we're going to break it down into 4 logical steps. First, we'll get a really precise definition of what tool use is. Then we'll map out the entire information flow, from the user's prompt all the way to an action. Third, we'll look under the hood at the logic that lets the model choose the right tool. And finally, we'll explore some of the powerful applications this pattern opens up.
Okay, let's dive into Section 1. We're going to establish a clear architectural definition for tool use.
At its core, tool use, and you'll also hear this called function calling, is the pattern that lets an LLM talk to external systems. Now, to be crystal clear, the LLM never executes any code itself. Its only job is to generate a structured piece of data, like JSON, that signals its intent to call a function. It's our applications code that actually does the work and executes the tool.
I think the best way to think about this is to imagine the LLM as an isolated brain. It's got this vast, self-contained knowledge. Tools are its interface to the world. They're the hands that allow that brain to go out and query live systems, perform actions, and pull in new information.
All right, on to Section 2. Let's really map out the entire end-to-end flow of a tool use cycle. We'll trace it from the moment the user types their prompt to the final answer they get back.
So, this shows the complete information loop. Let's walk through it step by step. First, it all starts with the user prompt that needs external data. Second, the LLM analyzes this prompt and decides that a tool is needed. Third, and this is key, the LLM's output isn't an answer. It's a structured JSON object that requests a specific tool. Fourth, our application code sees that JSON, parses it, and actually executes the function. Fifth, the result from that function call, say 22 degrees and sunny, is returned. And finally, in step 6, that new piece of data is passed back to the LLM, which now has the context it needs to create a final natural language answer for the user. That's the full round trip.
So, that raises a really important question, right? How in the world does the model even know what tools are available, or how to ask for them in the exact right format?
This is probably the most critical architectural principle to understand here. The LLM never executes code directly. Letting it do that would be a massive security hole. Instead, we, the developers, provide it with a structured menu or a manifest of the tools that it's allowed to use. The model's only job is to read from that menu and request an action. Our code is what handles all the execution.
So, let's break down what one of these menu items, the tool's signature, actually looks like. It's defined using a JSON schema. Now, look closely at the description field. This is the most important part for the LLM. It's a natural language description that the model uses to figure out if this tool is relevant to the user's question. Then, the parameters object defines the contract. It tells the LLM what data it needs to extract from the prompt to make the function call work. Honestly, writing clear, descriptive schemas, that is the key to making tool use reliable.
Okay, so we've got the definition, we've got the flow, and we've got the logic. In this last section, let's look at some real-world applications. This is where this abstract pattern really becomes a game-changing capability.
The applications for this are just huge. We can connect the LLM to live APIs for things like stock prices. We can give it tools for tasks it's bad at, like a calculator for precise math. We can give it access to a sandboxed code interpreter for complex data analysis, or even let it query our company's internal databases. And what's really powerful is that it's not just for getting data. We can define tools that trigger actions, like sending an email or creating a calendar event. This is what turns the LLM into a true agent. So here's the main takeaway. Tool use is the design pattern that elevates a model from just being a simple text generator, a kind of chatbot, into a genuine problem-solving agent. It becomes an active participant in your digital workflows, something that's capable of both reasoning and acting. So I'll leave you with this question to think about as you start designing your own agents. Now that you understand this pattern, what's the very first tool you're going to give your AI, and what problem are you going to solve with it?